Hi everyone, my name is Dan Low. In this video, I'm gonna talk a little bit more about project part 2, 8 by 256 decoder. So first, what is a decoder? A decoder basically is a component. So for example, 2 by 4 decoder, you got two inputs, I0, I1, and each of them is 1 bit input, and output O0, O1, O2, O3, 4 bits. So if you have 2 bits input in the decoder, you will have 2 to the 2, that's 4 bits output. If you have 3 bits input in the decoder, then you're gonna have 2 to the 3, 8 outputs. Okay. And when the input is 0, both I0, I1 are 0, then the O1 will be high. Okay, output 1, then O1, O2, O3 are 0. So only the O0 will be high when the input is 0. If the input is 2, that means I1 is 1, I0 is 0, okay, it's 2. Then the O2 will be high, and O1, O0, O3 will all be 0. So in all input combinations, only one of the outputs is high, the rest will be 0. That's a decoder. Okay, so based on the output, we know what's gonna be the input. So if you see O2 is high, that means the input is 2. If you see O1 is high, that means the input is 1. If you see the O3 is high, then the input will be 3. So in order to use VHDL to implement this component, so these are what you need. First, you need to understand range attribute in VHDL. I will revisit the slide I show you in the class. And you also need a process concept in VHDL, because without this process you cannot do the sequential signal selection statement. Therefore, you also need to understand the sequential signal selection statement. I'll show you later. And that's all you need. So now let's get back to the slides I showed earlier for the range. So here's the range. Okay, in VHDL. So let's take a look at this range. First, we define a port Q as output of type integer. The range of it is from 0 to 3. That means Q could be 0, 1, 2, 3. And something we can define input port of type integer with this range. Okay. So once we define that way, you can use d-tick range. Okay. So this attribute will tell the VHDL that we're going to iterate over the range of d from 0 to 3. So each time, in each iteration in this for loop, the I will get the value 0. Okay, and then this loop execute once. 1, execute once. I go to 2, let's go once. And the I go to 3, let's go once. Okay, so remember that this is in the process, and all the statements in the process will be executed sequentially. Okay, so what you have to do is you have to design something similar to this in the VHDL that will implement the function of a decoder. Okay, so with this range and this process, and the process syntax will start from process, that's the reservoir, followed by any signals in the sensitivity list, and followed by the variable you may need to use in the process. You can define it here, and followed by the begin keyword, and the end process keyword. Okay, so let's see. Let's use the IC to implement this. Okay, now I got an IC here. Let me reduce the screen size a little bit. Okay, so you can see everything. Okay, so this is IC. So I'm going to implement a 2x4 decoder. Okay, let's say example. So let's new a project. And I'm gonna set this project my 2x4 decoder. Okay, and then I'm gonna put it into drive D. Okay, and then next. And I'm gonna use the default versus 5 and XC5 VLS 110T and FF1136. That's the default. Okay, and then the rest of it, you see the XST, the compiler, the iSIM, the simulator, and then the default language VHDL. And click next. And this one I'm gonna create a new source. So I click a new source for the component, and which is gonna be the VHDL. Okay, so I click the VHDL module, and then I'm gonna name it the same name. My 2x4 decoder. Okay, and I'm gonna tick the add to the project and select next. And now I need the input and output. So in this 2x4, I know the input will be 2 bits, which is 0 to 3, right? So I put the input port name, say input, or maybe just put I input. Just say A, whatever, input A. And the direction is in, and then I'm going to need the 2 bits, right? So I set this to 1 to 0, 2 bits, and then the output I'm gonna set it to Y. Okay, then I set it the output, and it also a bus, so the most even bit is 3 down to 0. Okay, and next. So after I've done that, then I click finish. You'll create one force. Okay, then, and that's all I need. So I click next, and then I don't have any existing source to be added in. So just click next. Now click finish again. That's the summary of the project you have just created. So once I get into the project IDE windows, I got a component created. My 2x4 decoder is A, that's input standard logic vector, and the architecture is automatically created for you. Okay, so that's very convenient. Okay, if you're not familiar with the VHDL, then this is a good way to get you started. So now I need to modify the input from the standard logic vector to integer. Okay, so I say this is integer type, and then range. I use range from 0 to 3. Okay, so after that I save it. Now inside the body of the architecture, okay, I need to put a process there. Okay, so I use process as a keyword, and then followed by any signals go inside. So I say A, that's a signal, the only signal. Okay, is process is then begin. If you if you forget the syntax, you can go back here. Okay, so that process D, oh, we don't have a is, so this is begin. Okay, so you can say begin. Okay, then end process. Okay, so so inside the process, you can put a comment here. Say this is process to implement 2x4 decoder. Okay, so in the process we need the for loop, right? So you can say for I in the range, okay, loop, which is exactly the same thing as here, right? For I in the range loop, right? And then end loop. Okay, so end loop here now. Okay, so inside the end loop, what do I need? I need to implement the sequential signal selection. So I use if. Okay, if uh, if let me go back here. If di is equal to 1, then we do something, right? So now we need to check the number. Okay, so we need to do the signal. Okay, a if a input equal to I. Okay, that's the syntax, right? If something equal to something. Okay, then if a, the input is equal to I, then what happens? Then the output y sub I, right, it's assigned 1. Okay, then else if I is not equal to a, that's a, then the output should be 0. Okay, and don't forget you have to close by and if. Okay, and then that would do it. So let's save it. Okay, and then check syntax. Okay, then that's a design utility. You can hold on one second. You can synthesize, but before you synthesize, you can check the syntax here. So double click to check syntax to see if anything wrong. And meanwhile, you can enlarge the console a little bit so you can see the output. Okay. So here we got something wrong here. It says the prefix attribute tick range must be an array object. Array or object. Okay. So A, now we say the integer range 0 to 3, or it may not be correct. Okay, so let's get back to the syntax here. So here we define integer range 0 to 3. That's Q, or the D is the standard logic vector right here. Standard logic vector. Okay, so we need to actually iterate over each bit, not the range of the integer. Okay, so we modify it a little bit. Instead of going over the A, we're going over Y tick range. Okay, so now I will go over the range of Y, which is 0, 1, 2, 3. Okay, In that case, we still can compare a to I, and then yi will assign to 1, otherwise yi assign to 0. Save it and check the syntax again. The reason I like to check the syntax because when you synthesize the circuit, it may take longer, to compile. So I need to make sure that the syntax is correct first. Okay. So now the syntax check is complete. So the second step is we can synthesize it. Okay. So this may take some time. Okay, but anyway, it should work. So now you see the syntax completed. That means everything should be fine now. Okay. Okay. So what's next? So we need to create a test bench to see what's gonna be the output. So to create a test bench, you go project and then new source, and then click on the VHDL test bench. Then type in the name my 2x4 decoder and then underscore TB. That'll be the test bench decoder. Okay, and then click next. Then you have only one component, so select it. Select the component you have, then finish. So the system will give you a test bench file in VHDL. So all you have to do is you scroll down to the process for the stimulus input. So here we first wait 100 milliseconds. That's the system suggestion for the input. Okay, and then since this is combinational logic, we don't need a clock, so we can comment this out. Okay, then we start giving the input. So for the test case, so this is test number 1, for example. So the test number 1, what I'm going to do is I'm going to set a, that's input, right, equal to since a is integer, right, so a is 0, starting from 0. Okay, and then I'll wait for about 10 nanoseconds. Okay, then I assert that y must be since y must be 4 bits, right? So it must be 0000 4 bits. Otherwise, I report error. Test number 1 error, and followed by the second case number 2. I want to set the a to 1. Okay, then wait for about 10 nanoseconds. Okay, then I assert y equal to 0 0 1 0. Sorry, 0 yeah, 1 0 0 0 1 0, and this is 0 0 0 1. Sorry. Okay, and then similarly I'm gonna set a test case 3 and 4. So this case 3, a equal to 2, then it's 0 0 1 0, and then this case 4, that's 3, so this is 1 0 0, and this is test case 4, test case 3, test case 2. Okay, so after that, save it, and you can change the implementation to behavior simulation and select the decoder test bench. And first we can check the syntax of this test bench. It gives you some errors. Let's see what's the errors. Let's go up to the first one. So here we have the clock, something wrong. Actually we don't need a clock. Okay, so we can just remove it or mark it out, comment it out. and then save it, check it again, and we look at some errors. Here it says type standard logic vector does not match with which one? A is the standard logic vector, but we changed it to the integer, right? So we need to modify this a little bit. So let's change it up to integer. Range 0 to 1 to 3. Okay. Then the second one A again. We need to change this to integer 0 to 3. Okay. Then the initial value we can set it to 0. And then check it again. Okay, now syntax is correct, so we can ready to simulate the circuit by double click the simulate behavior model. And just wait a little bit for the iSim to bring up the waveforms. And this waveform gonna be displayed based on our test case design. Okay, so here it is. So let me reduce the size of the screen so you can see the whole thing. Okay, so here it gives you the input A, output Y, and the waveform. So in the waveform, we can move the waveform to somewhere here. Okay, then we can since this is picosecond scale, that's way too small, so we can zoom out. Okay. Okay, so now we got okay, so at this point that we only got one case. Okay, one case. Okay, so we might need to enlarge the simulation to 1. Right now it's 1 microsecond, right? So we may change it to 100 microsecond. Okay, and then run. Okay, so still not, so I guess we need to run longer, 150 millisecond. Okay, and now we got 0, 3. Okay, still may not be quite okay. So this 0 and then this 3. So 0 and 3. It only show 2 cases for some reason. Okay, so we need to double check. Why is 0 and then jump to 3? It should be 0, 1, 2, 3, right? But 0 it displays 0, 0, 1. That's correct. And 3 input, the output is 1, 0, 0. That's correct. So close this. Come back to check why it does not show 0, 1, 2, 3. Okay, here we wait for 100 milliseconds. I think that's we're gonna wait just 10 milliseconds. Okay, wait too long. And after that, we set input A and wait for 10. Then check. Okay, and set the input A to 1 and then wait for 10 milliseconds. and then set the input. Wait for 10 seconds. Okay, it seems okay now. So let's save it and then simulate it again. Okay. So now we got something like okay, it seems okay. I see some 0, 2, 1, 2, 3 here. Okay, so now we got the test case 1 here, which is the A0 and then the Y001 is correct, and test case 2, A is 1 and the Y is 010, that's correct, and the case 3 A is 2 and Y is 0100, that's correct. So at this point, all 4 test cases are correct. So that's all I have for this video. Okay, see you next time. Bye bye.